Hello students, welcome to my class. In today's class we are going to learn a new chapter, chapter 10, straight line of class 11. Actually this chapter is a continuation of the concept coordinate geometry which you have studied in your earlier classes, like in class 9 and 10 we have studied coordinate geometry. So what are the important concepts we have studied there? The coordinate axis, coordinate plane and plotting of a point in a plane, distance between two points, section formula, area of a triangle. So all these concepts we have already studied. In this chapter we are going to learn about the properties of straight line. So that is various forms of straight line, general form of a straight line. So before going deeper into the concept straight line, first we should know some basic terms. So first one is slope of a line. What do you mean by slope of a line? So let us consider a line in the coordinate plane. Let us consider a line L in the coordinate plane. Suppose if we extend this line, this will intersect the x-axis and it will make an angle theta with the positive direction of x-axis. So here if we extend this line, we are getting two angles. One is an acute angle and another one is obtuse angle. So this angle, the angle made by the line with the positive direction of x-axis measured in the anti-clockwise direction. So this angle is known as inclination of a line. So what do you mean by inclination of a line? The angle made by a line with the positive direction of x-axis measured in the anti-clockwise direction. Now what do you mean by slope of a line? That is, the tangent of this inclination is called the slope of a line. So slope of a line is, another name is gradient. Slope or gradient of a line is the tangent of the inclination. That is, this is the formula. Slope of a line is equal to tan theta, where theta is the inclination, of the line. So here slope of a line is represented by the letter M. So M is equal to tan theta. So this is the formula. This is slope of a line. So one more time let me repeat. Slope of a line is the tangent of the inclination of a line. So M is equal to tan theta is the formula for slope of a line. So if the inclination theta is not given, then how to find the slope? We'll see now. Suppose if 2 points on the line L is given, then how to find the slope? We'll see now. So P x1 y1 and Q x2 y2 are 2 points on the line L. So if this line makes an angle theta with the x-axis, positive direction of x-axis, let us take this angle as theta. Now we have to find the slope of this line L. So we'll draw a perpendicular from Q to x-axis. We'll denote this as QR. And another line from P, will draw a perpendicular to QR. We will denote this as PM. So PM is the perpendicular to the line QR. PM, here the coordinate is x1, y1. Okay. So we have drawn two perpendicular. One is from Q to x-axis and another perpendicular PM to QR. This PM is parallel to, actually this PM, line PM is parallel to x-axis. So what about these two angles? Actually these two angles are corresponding angle. So if this angle is theta, then this angle also will be theta. Okay, so we will get this angle as theta. Now you know the formula for slope of a line, that is m is equal to tan theta. So in this triangle, in this right angled triangle PMQ, we are going to find the tan theta value that will give us the slope of the line. So how to find tan theta? You know the formula for tan theta, opposite side by adjacent side. So here opposite side is QM divided by adjacent side is PM. Now we are going to find the value of QM and PM and we are going to substitute in this. We are going to find the length QM. So QM we can write as QR minus MR. So QR minus MR. So what is QR? Actually QR is this distance, okay? So the y coordinate of the point, QR is nothing but the y coordinate of the point, that is y2 minus MR. MR means this distance only. Actually MR and PS, if we denote this point as S, then this distance MR and PS are same. And what is this PS? PS is the y coordinate of the point P. So PS will be y1, so MR is also y1. So MR, in the place of MR we can write y1. So we got the value of QM. Similarly we are going to find the PM value. So how to find this PM? PM is nothing but SR. This distance, both PM and SR distance are same. So if we denote this point as O, okay, we'll denote this point as O. So how to find this SR or PM is equal to SR we can write as OR minus OS. OR minus OS, and you know that this OR distance is the X coordinate of this point Q. So X2 minus and OS is the X coordinate of the point P. So X1. So we got PM value as X2 minus X1. Now we are going to substitute these values in this equation. So we'll get tan theta is equal to Y2 minus Y1 by X2 minus X1. So this is the formula for finding. You know that tan theta is nothing but the slope. So this is the formula for finding the slope of a line if the coordinate of 2 points are given. So if P x1 y1 and Q, if P x1 y1 and Q x2 y2 are points on line L, then slope of L formula is y2 minus y1 by x2 minus x1. So this is the formula for finding slope of a line if 2 points are given. So if the inclination angle is given, then this is the formula, slope is equal to tan theta. If the coordinates of the point, 2 points on the line is given, then the formula is y2 minus y1 by x2 minus x1. Now we will see what is the slope of x-axis and y-axis. Slope of x-axis and y-axis. So we have already learnt the formula for slope. M is equal to tan theta, where theta is the inclination. Suppose if we have a line parallel to x-axis or coinciding with the x-axis, in that case what will be the inclination? Here for this line, what is the inclination? Inclination is 0 degree. So for this line L, the inclination is 0 degree. So what is the slope formula? M is equal to tan 0 degree, which is equal to 0. So for a line parallel to x-axis or coinciding with the x-axis, the slope is 0. So slope of x-axis, we can say that slope of x-axis is 0. Now you consider, let us consider another line L which is parallel to y-axis. Consider a line L parallel to y-axis. So here in this case, what is the inclination? So inclination is the angle made by the line with the positive direction of x-axis measured in the anti-clockwise direction. So if a line is parallel to y-axis, this angle will be 90 degree. So for a line which is parallel to y-axis, inclination will be 90 degree. So in that case, slope m is equal to tan 90 degree, which is not defined. We know what is the value of tan 90 degree, which is not defined. We can say that, so we can say that slope of y-axis is not defined. So these 2 points you have to remember. So first one, slope of x-axis is 0 and slope of y-axis is not defined. We are going to learn condition for parallelism. What is the condition for parallelism of lines in terms of slope? So let us consider two lines, L1 and L2. So the first line is L1 and the second line is L2. Let us consider two parallel lines. L1 and L2 are actually parallel. So let us consider two lines L1 and L2 which are parallel, and the slope of the first line, we will take a slope of L1 we will denote as M1, and slope of second line L2 will denote as M2. Now we are going to see the condition for two lines to be parallel in terms of slope. So here first let us take the angle made by the inclination of the first line L1 as alpha. We'll denote the inclination of first line L1 as alpha. The second line L2 makes an inclination beta. And we know that since the lines L1 and L2 are parallel, actually these two lines are, these two angles are corresponding angles. So we can say that alpha and beta are equal, corresponding angles are equal since these two lines are parallel. So we can write alpha and beta are equal. Now we are going to take the tan on both the sides. So we can write tan alpha is equal to tan beta. But what is this tan alpha? Alpha is the inclination of the first line and the tangent of alpha will be equal to the slope of the first line, which is denoted by the letter M1. So we can write tan alpha is the slope of the first line and tan beta is the slope of the second line. So we can say that M1 and M2 will get M1 and M2 are equal. That is, if two lines are parallel, then their slopes are equal. This is a very important condition. This is the condition for parallelism of lines. If two lines are parallel, if L1 and L2 are parallel lines with slopes M1 and M2, then their slopes are equal. So this is the condition for parallelism. So if two lines are parallel, then their slopes are equal. Next we are going to see the condition for perpendicularity of lines. Consider two perpendicular lines in a coordinate plane. Let us consider two perpendicular lines. So L1 and another line is L2. So these are the two lines perpendicular to each other. So L1 and L2 are perpendicular to each other and this angle is 90 degree, and the alpha is the inclination of the first line and beta is the inclination of the second line. So you know that what is the slope of the first line? M1. Since the inclination is given, M1 is equal to tan alpha. And what is the slope of the second line? Inclination for the second line is beta. So m2 is equal to tan beta. Now we are going to find the condition for two lines to be perpendicular in terms of their slopes. So let us consider, we will denote this point as ABC. Okay, we will denote these points as ABC. So we will consider this triangle ABC. So in triangle ABC, actually this alpha is the exterior angle. So we know the formula for, we know the property of exterior angle. Exterior angle will be equal to the sum of interior opposite angle. That is, this alpha will be equal to beta plus this angle. So what about this angle? Since these two are vertically opposite angle, this angle is also 90 degree. So we will get the equation alpha is equal to beta plus 90 degree. Okay, so exterior angle is equal to sum of interior opposite angle. So you will get the equation alpha is equal to beta plus 90. Now we are going to take tan on both the sides. So tan alpha is equal to tan of beta plus 90 degree. So what is tan beta plus 90 degree? This we have already studied in trigonometry chapter, trigonometry functions chapter. So tan of beta plus 90 degree is cot beta, and since this angle lies in the second quadrant where tan is negative, so you will get minus cot beta. Again, this cot beta we can write as 1 by tan beta. Okay, so we got tan alpha is equal to minus 1 by tan beta. And what is tan alpha? M1. So M1 is equal to minus 1 by tan beta is M2. When you cross multiply, we will get the condition M1 into M2 is equal to minus 1. So this is the condition for perpendicularity. So if two lines are perpendicular with the slopes M1 and M2, then the product of the slopes will be equal to minus 1. So this is the condition for perpendicularity of line. So let us see few example question. Example 1, find the slope of the line. First case, passing through the points 3, minus 2 and minus 1, 4. Here in the first question, the coordinates of the points are given. We have to find the slope. So you know that what is the formula for slope if the coordinates of the points are given. So slope m is equal to y2 minus y1 by x2 minus x1. So this is the formula. So here the coordinates of the points are 3, minus 2 and minus 1, 4. So the coordinate of the first point we will denote as x1, y1 and the second point x2, y2. Now we are going to substitute the values in this formula. So y2 minus y1, that is y2 is 4. So 4 minus y1 is minus 2 divided by x2 is minus 1 minus x1 is 3. So we will simplify. So 4 plus 2, 6 divided by minus 4. So when you simplify, you will get minus 3 by 2. Therefore, slope of the line passing through the given point is minus 3 by 2. Now the second question, in the second question what is given? Inclination, theta value is given. We have to find the slope of the line. So theta is given in the second question, theta is given as 60 degree. So what is the formula for slope? M is equal to tan theta, that is tan of 60 degree. Tan 60 degree is root 3. So for the second case, the slope of the line is root 3. So this is how we have to find the slope. If angle theta inclination is given, then we have to use m equal to tan theta formula. If the coordinates of the points are given, then we have to use this formula. Now we will see another example. So example 2, line through the points minus 2, 6 and 4, 8 is perpendicular to the line through the points 8, 12 and x, 24. Find the value of x. And actually here in this question, We are given the two lines are perpendicular. This condition is given. Perpendicular condition is given. So we have to use the condition for perpendicularity. So what is the condition for perpendicularity of a line? If two lines are perpendicular, then product of the slope is equal to -1. So first let us find the slope of these two lines. So slope of the line passing through the points -2, 6 and 4, 8. We will denote the slope as m1, and you know the formula y2 minus y1 by x2 minus x1. So 8 minus 6 divided by 4 minus 2. So that is 8 minus 6 is 2, 2 by 4 plus 2 is 6. When you simplify, you will get m1 as 1 by 3. Similarly, we will find out the slope of the line, second line. So slope of the line passing through 8, 12 and x, 24. We'll denote the slope as m2. So m2 is equal to y2 minus y1. So 24 minus 12 divided by x2 minus x1, x minus 8. So we will simplify this. So 24 minus 12 is 12 by x minus 8. Okay, so we got the slope of the two lines. Now we will use the condition. Since the lines are perpendicular, we know the condition m1 into m2 is equal to -1. So what is m1? 1 by 3 into what is m2? 12 by x minus 8 is equal to -1. So we will cross multiply, we will cancel here, then we will cross multiply. So 4 is equal to minus of x minus 8. So we will simplify this. So 4 is equal to minus x plus 8. So minus x is equal to, we will get minus x is equal to 4 minus 8. That is minus x is equal to minus 4. So the value of x is equal to 4. So this is how we have to use the condition for perpendicularity to find the value of x. So in today's class we have learned the slope of a line and condition for parallelism and the perpendicularity of lines. In the next video we will learn more about straight line. If you like my channel, you can share and subscribe. Your subscription, my motivation. Thank you, children.